All right, so we've talked about this in the past, the great machine learning circle of life, and I've kind of simplified it. AWS uses a slightly different view of this, but basically we have our goal over here, what we're trying to achieve with our machine learning project. We have the data that is going to help us achieve that goal, hopefully through the use of some fancy mathematics and machine learning. And then we have to figure out how are we going to approach this problem given the data that we have. What tool in our ML bag of tricks are we going to pull out and apply to this particular problem? Then we are going to develop an approach. We would probably develop a model, something like that. And then ultimately we would deploy that. We would put that out in production and make use of it. Now, ideally, we're going to profit, right? Everything is going to be great. But we want to be sure that we do not turn this into a giant public humiliation. So therefore, there are some things that we need to do both in the early stages here and the later stages and once we are in production to make sure that our model, our beautiful model, doesn't turn into a public humiliation. So one of those things that we need to do is we need to measure how well our model is doing what we think it's supposed to be doing. So oftentimes we will measure in the development stage, and we will measure once we deployed it out into production, and we really should measure to see if it's actually having the intended goals or having the intended impact that our goal or our problem was set up to expect. Now, there's another aspect too, and that is to analyze all this stuff. And we can do that independent of measuring. And when I say analyze, we're able to look at our data even before we get to our approach or we develop anything. We can look at our data and say, hey, this data doesn't look quite right. We might need to collect some more data or collect it in a different way. And then also we can look at the results of our model and we can see, okay, is it truly having the intended consequence or is it having some unintended consequences? Maybe this model is behaving in a way that we did not expect. And that is very, very common with machine learning models because more or less they're just big black boxes. And it's not always obvious why those machine learning models are making the decisions they are making. So one of the things we need to be aware of is this concept of bias. And bias is not always a bad thing or a good thing, it's just a thing. It is a way that we can introduce error into our model through the data we choose, what sort of approach we take, what choice in algorithm, how we interpret the metrics, and also just as us being humans, we have our own inherent biases. So that if we're looking at some test results, for example, and we really, really want this project to go through, we may be inclined to kind of decide on the side of the project versus decide on the side of maybe pulling the plug. Now, there are many different types of biases, and kind of the two, uber types of bias in machine learning is statistical bias and model bias. Now, bias in a model is something slightly different than statistical bias, and what I'm going to focus on here is generally statistical bias. And when we talk about bias in a model, a lot of times what it means is the tendency of a particular step or a weight in that model to go one way or another. And we're not necessarily talking about bias in like a discriminatory way in that respect. So whenever you hear the word bias, don't just always assume that it means some sort of negative, horrible thing. It is just a thing, at least in machine learning. So talking about statistical bias, here are what I would consider and several others consider kind of the top 5 biggies of machine learning bias when we're talking about statistical bias: selection bias, sampling bias, label, measurement bias, and confirmation bias. And I'm going to go through and define each one of these so you know what it is, and then I'm going to give you an example. So the first one up here, selection bias, is the data that we happen to have chosen is not necessarily representative of how things work in the real world or how the model will be used in the real world. And so you can see that would definitely introduce some error in our expected outcome. Now, sampling bias is a subset of selection bias, and that's when we don't necessarily get a fully random sample. So if we happen to be cherry picking certain values because they are convenient, then that's not really a truly random sampling. And academic studies suffer from this all the time because there's this tendency to go for the data that is already captured or the data that is easy to get to versus maybe the data that's really going to reveal something about that particular hypothesis. Next, we have label bias, and this is reflected in how our data is labeled. So especially if we have humans labeling our data, if you remember we did that little exercise where we used ground truth to assign out our Lego faces for labeling. Well, because humans were doing that labeling, they are prone to error, and maybe sometimes they make a mistake, or maybe they put something in based on their own background or their own experiences, and maybe that's not the correct answer. So that can affect our model development and ultimately our outcome. Measurement bias is another bias that gets introduced if maybe we have some flaws in how we are collecting that data. Maybe our methodology isn't so great. Maybe we have some sensors out there that are giving off bad data. Or maybe we decided to use one measurement or one value as a representation of some other concept, and that's often called proxies. So we can use this one attribute and say, okay, well, if this one attribute exists, then it means that this other thing exists as well. So that is common in machine learning when you don't have access to that other attribute, for example. You can use proxies, but you have to be really, really careful. And you'll see why in the examples that I give. Then finally, we have confirmation bias. And that just means that we tend to believe the things that we already believe in, or we're going to gravitate towards those things that agree with our own beliefs. And that can be done in what data we select, what summarization we give to the results of the model, how we interpret things. So we could run a model and we can have some results, and then maybe we're standing in front of a boardroom reporting out the results. And like I said before, because we really, really want this thing to go through, we may be a little bit too positive, and that is interpreted by maybe the CEO and the CIO and stuff like that as maybe the results are better than they actually are. So we have to be very cautious about that as well. Now, here are some examples of these types of bias. For selection bias, it happens to be using some data that's already available and easy to access versus some data that's more difficult to access. For sampling bias, maybe we're doing a political survey and we only have a list of people that have landline phones. Now, if we just did a survey with these people that only have landline phones, well, you can see there are a lot of people who do not have landline phones, and so we are not getting a true representation of the overall population. Now, if we were to say, hey, this political survey is only for folks that have landline phones, then yeah, that would be accurate. But generally speaking, you're not going to have little segmentations like that when you're talking about political surveys. And this stuff happens all the time, as evident by many political surveys are often drastically wrong than the election outcomes. Then for label bias, we're going to go back to the Amazon example I used in the intro, and that is we are assuming that past hires have the attributes, they have the characteristics that we want to see in future hires. Well, maybe they do from a technical standpoint, but there are a lot of other attributes that come together to form a human. And so just saying the absence of those attributes means that they are not appropriate for a hire is something that's not really good, and it's going to lead to errors in your model. Now, moving on to measurement bias. Well, there's a good example in history, and it's a very unfortunate example, of something called redlining. And the idea there is that certain organizations would literally draw red lines around areas on a map that were predominantly lower income, and in many cases, minorities lived in those areas. And in that situation, what some of those organizations were doing is they were using geographic location as a proxy for credit worthiness. So banks would look at these red line maps and they would say, okay, you live in this particular zip code, therefore your credit worthiness is not as high as somebody else who lives in this other zip code. Now that was done back in the day, but some of that stuff kind of still lingers on today. And it wasn't done in a malicious way. at least initially. The reason it was done that way is because they really didn't have any other way to measure credit worthiness very well. But unfortunately, the unintended consequence there is that folks living in those areas tended not to get loans, business loans or home loans, and those things had generational impacts down the line. And that was an example of bias where this proxy, this kind of arbitrary postal code, was used, and ultimately it had very, very bad unintended consequences. And some may argue that it in fact had intended consequences, but I'm not going to go into all of that. And finally, we have confirmation bias. And a good example of this is, let's say you have a social media platform and there are certain type of people that gravitate towards your social media platform, and you have a moderation feature on there. And you allow those people to decide what sort of social media posts are good and bad, or what are appropriate and not appropriate. Well, if you happen to have a site that caters to a specific demographic or political leaning or something like that, you can see where that would probably cause some problems with regard to getting a fair assessment of whether or not that post is truly appropriate or not, because the folks who are already there have their own opinion. So in one way you can say, well, it's just self-policing and they get more of what they want to see. The downside is that really homogenizes the type of information on that platform, and it can drive it into some pretty dark areas. So even though we say, hey, crowdsourcing is a great resource, well, we also have to look at where is that crowdsourcing resource coming from? Are they representative of our greater target audience? Now, there are tons of different kind of bias. I'm going to direct you to something called the Cognitive Bias Codex, and I'm going to link to it down below in the text. Probably one of my favorite quotes here on bias is from Fifi Lee. The greatest risk of AI is not superintelligence, it is the amplification of existing biases at scale. So I would really ask for you to take some time to think about this, go out to this Cognitive Bias Codex and kind of look around at these different types of bias and see if you can identify how some of these bias have crept into your life. And don't feel bad, everybody has biases. It's part of being human. It's part of how we evolved to survive. But we need to be really aware of how they impact what we're doing with regard, in this case, to machine learning and AI.